this video we're going to talk about sequences. First, let's start with a definition. A sequence is a function whose domain is the set of positive integers. Alright, so domain means the input, so this is what goes into the function. And positive integers, talking about positive 1, positive 2, positive 3, positive 4, and so on. So we're not allowed to put any fractions or negative numbers or 0 into these functions. Alright, so let's look at example 1. It says, given the function f of n is equal to 1 over n plus 1, evaluate the function for n equals 1, 2, 3, and 4. Alright, let's start with n equals 1. We'll put a 1 into the function everywhere that we see an n. We'll simplify. I get 1 over 2. Alright, let's go for n equals 2. I'm going to put a 2 into the function everywhere that I see an n. And I get 1 over 3. Alright, let's go for n equals 3. Put a 3 into the function everywhere that you see an n. We'll get out 1/4. Now n equals 4. Put a 4 into the function everywhere that we see an n, and we get out 1/5. The output values that we get out are called the terms of the sequence. So the first term of the sequence would be 1/2. The second term of the sequence would be 1/3. The third term of the sequence would be 1/4. The fourth term of the sequence would be 1/5, and so on. Can you make a guess as to the next term of the sequence? Okay, so it looks like it would kind of go in this pattern, right? So the first term came from n equals 1. The second term comes from n equals 2. The third term came when n equals 3. The fourth term comes when n equals 4. So the n value basically tells you what term of the sequence that you're generating. So if you want to generate the first term of the sequence, you plug in n equals 1. If you want to generate the second term of the sequence, you plug in n equals 2. Third term of the sequence, n equals 3. Fourth term of the sequence, n equals 4, and so on. What if we wanted to find the 17th term of the sequence? How would I find that? Well, go to your function and plug in n equals 17. So f of 17 then will give us 1 over 17 plus 1. I get 1 over 18. So to generate a term of a sequence, we're going to plug in the n value for whatever term we're looking for. Now let's look at a slightly different notation for sequences that we will be using more frequently. Here we have d sub n. So d actually in this case is going to represent the name of the sequence. And I said sub n, that's what we would call this little subscript. N here is going to represent the term number. What we have on the other side of the equal sign in these brackets, this is going to be the formula to find terms. Okay, we call this the nth term notation. In this example, we're asked to find the first 4 term of the sequence using this new notation. So let's say that we're asked to find the first term. To find the first term of the sequence, we're going to set n equals to 1. So everywhere that we see an n, we're going to replace it with a 1. So that's d sub 1 is equal to negative 1 to the power of 1 all over 1 times 2 times 1 minus 1. Okay, we're going to simplify that. Negative 1 to the power of 1 is negative 1. That's 1 over, let's see, 2 times 1 is 2, 2 minus 1 is 1. So when I simplify that a little bit further, that's negative 1 times 1, we get negative 1. So the first term of the sequence is negative 1. Okay, now we're going to find the second term of the sequence. To find the second term of the sequence, we set n equal to 2. So I have d sub 2 is equal to negative 1 to the power of 2 all over 2 times 2 minus 1. Alright, so to simplify this, d sub 2 is equal to negative 1 squared. Right? When we square a negative, we get a positive, so it's a positive 1. And then we have at the bottom 2 times 2 is 4, 4 minus 1 is 3. So the second term of sequence D, or d sub 2, will be equal to a positive 2/3. Alright, let's find the third term of the sequence. Alright, we'll set n equal to 3. So d sub 3 is negative 1 to the power of 3 all over 3. Let's see, we have 2 times 3 minus 1. Alright, now we'll simplify that. Negative 1 cubed, well that's a negative. It's negative 1 times 3 over, see, 2 times 3 is 6. 6 minus 1 is 5. So the third term of our sequence, or d sub 3, is negative 3/5. Alright, we're asked to go all the way to the fourth term. Alright, so to find the fourth term, we're going to set n equal to 4. So d sub 4 is equal to negative 1 to the power of 4 times 4 over 2 times 4 minus 1. And simplify that. Negative 1 to the power of 4, that's a positive 1. And I have 4 over, it's at 8 minus 1, which is 7. So the fourth term of our sequence is a positive 4/7. Now we could continue on from here, finding the fifth term and the sixth term and so on. But we're only asked to find the first 4 terms. So we'll stop there. I do want to point out something about these terms. You'll notice that the signs alternate. So this is called an alternating sequence. It's called an alternating sequence because the signs change from term to term. So it goes from negative to positive. Third term is negative, the next term is positive. So we will see that that pattern would continue on in an alternating pattern. So what makes this alternating sign pattern happen? The alternating signs are actually coming from the negative 1 to a power. So if you have negative 1, and the parentheses are important because the negative is part of the duplication. If you have negative 1 to an odd exponent, then you will always get a negative 1. If you have negative 1 raised to an even exponent, then you will get a positive 1. This is going to come in handy a little bit later, and we will look at this again on the next page of notes. Here we have sequence A, and once again we're asked to find the first 4 terms of the sequence. So if I want to find the first term of the sequence, we're going to set n equal to 1. So we have a sub 1 is equal to negative 1 to the power of 1 plus 1. So all of that is in the exponent. And we have 1/3 to the power of 1. That's negative 1 in parentheses squared times 1/3. Negative 1 squared, anytime we have negative 1 raised to an even exponent, we're going to get positive 1 times 1/3. So a sub 1 is a positive 1/3. Something that we want to mention here is When we're talking about terms of a sequence and we have fractions, we always want the exact value of the fraction. We will never want to work with decimal approximations. So my first term should be 1/3. I don't want to say that the first term is 0.33333. Okay, so we don't want any decimal approximations or just 0.33. Sometimes people do that. Both of those are decimal approximations. We want the exact fraction. So we're going to leave it as 1/3. All right, what's the second term of our sequence? We're going to set n equal to 2. So a sub 2, that's -1 to the power of 2 plus 1, times 1/3 to the power of 2. So a sub 2 is -1 to the power of 3 times 1/9. So when we square a fraction, we square the top, we square the bottom, so we get 1/9. All right, so a sub 2, -1 to the power of 3. 3 is an odd exponent, so we get -1 times 1/9. So the second term of our sequence is -1/9. All right, so what is the third term of our sequence? We're going to set n equal to 3. So a sub 3 is equal to -1 to the power of 3 plus 1 times 1/3 to the power of 3. So that's -1 to the power of 4. Cube the top, 1 cubed is 1. Cube the bottom, 3 to the power of 3, or 3 cubed, is 27. So a sub 3 is equal to -1 to the power of 4. 4 is an even exponent, so we get a +1 times 1/27. So a sub 3, or the third term of our sequence, is a +1/27. Right, so now we want the fourth term of our sequence. We'll set n equal to 4. A sub 4 is equal to -1 to the power of 4 plus 1 times 1/3 to the power of 4. That's -1 to the power of 5. Raise the top to the power of 4, so 1 to the power of 4 is 1. 3 to the power of 4 is 81. We have -1 to the power of 5. 5 is an odd exponent, so that gives us -1 times 1/81. So the fourth term of our sequence is -1/81. Okay, we could keep going and finding the fifth and sixth and so on terms, but we're only asked to find the first 4. Again, when we look at these terms, we see that the sign changes as we move from term to term. The sign alternates. Starts with positive, negative, positive, negative. So this is also called an alternating sequence. It starts with positive, and then goes to negative, and then positive, and then negative, and then it will continue with that pattern as it goes forward. Okay, what makes that pattern happen? That alternating sign pattern again comes from this part of our formula, the -1 in the parentheses raised to a power. Once we plugged in and we simplified, we got -1 to an even exponent, -1 to an odd exponent, and then -1 again to an even exponent, and then -1 to an odd exponent. So the exponent changing from even to odd is what causes the sign to alternate. Alright, so at this point, given any nth term formula for a sequence, you should be able to tell me the first 4 terms of that sequence.